Now we have another way of doing the factorization of algebraic expression using the identities. We've already discussed identities in the algebraic expression session, so we'll not talk about what are identities, but we'll see how do we use them for factorization purposes. Some expressions can be directly factorized using the standard identities. An expression of the type x square plus 6x plus 9 can be directly factorized using the identity x square plus 2ab, a square plus 2ab plus b square is equal to a plus b whole square. Now if you match the given expression x square plus 6x plus 9 with a square plus 2ab plus b square, we'll find that a is equal to x and b is equal to 3. So this expression becomes x plus 3 whole square. Similarly, some identities of the type a square minus 2ab plus b square is equal to a minus b whole square can also be used to factorize the given expression. To factorize, now let's take another example where we have to factorize x raised to power 8 minus y raised to power 8. We can clearly not use the above two identities that we've talked about. The identity to be used here is a square minus b square is equal to a minus b into a plus b. So now if we match the given expression with this identity, we know x raised to power 4 is equal to a and y raised to power 4 is equal to b. And we get this expression as x raised to power 4 minus y raised to power 4 multiplied by x raised to power 4 plus y raised to power 4, and this could be further factorized if possible. Now some other identities that could be used for factorization are a cube minus b cube is equal to a minus b into a square plus ab plus b square, and second identity a cube plus b cube is equal to a plus b into a square minus ab plus b square. So these are the identities which could be commonly used for factorization of the expressions. Now let's see one more method that we use for factorization of algebraic expressions, but this is very specific to the cyclic expressions. So this is called factorization of cyclic expressions. Now let's first understand what are the cyclic expressions. Now let's first take an example. Expression of the type a multiplied by b plus c plus b multiplied by c plus a plus c multiplied by a plus b are called cyclic expressions. Now let's try to understand what is so special about this expression. Now this expression, if you see it, the first term, which is a multiplied by b plus c, is in a way similar to the second term and third term, with the difference that you can obtain the second term by just cyclically replacing each alphabet. So here in the first term, if we replace a with b, b with c and c with a, we get the second term. And similarly, if we replace a with c, b with a and c with b, we get the third term. So this is cyclic in nature. So these kind of expressions are called cyclic expressions, where we can just get the repeated terms, the second term and third term and fourth term and so on, if there are more than one variables present in that. If we can get this type of the next terms just by cyclically replacing the letters, these type of expressions are called cyclic expressions. So now they have a special way of factorization. In such expressions, we first open the brackets to get the expression with basic terms. So we get, in this expression, if we see, we'll get AB plus AC plus BC plus BA plus CA plus CB. So we'll open the brackets in these kind of expressions, and then we'll arrange the terms in ascending or descending order of one of the variables. So we'll see that, okay, there is a first variable, say a, which has a power of 2 or a power of 3 or a power of 4 as the highest power. So we'll arrange that as the first term, and then we'll arrange them in the descending order, or we could do it other way around. We take the a to the power 0 in the first as the first term and then arrange them in the ascending order of their powers. We'll then use the method of common factor to factorize the expression. The common factor method might be used more than once to do the complete factorization of such expressions. So it may not happen in the first step itself. You may have to repeat the step a number of times to get the final factorization of the expression. We'll see how we do that with the help of an example. Now, the example here is we have to factorize a square multiplied by b minus c plus b square multiplied by c minus a plus c square multiplied by a minus b. Now, let's see what do we do to factorize this expression. We first open the bracket as we talked about. So, it becomes a square b plus a square c plus b square c minus b square a plus c square a minus c square b. Now, if we rearrange them, as we said, we'll rearrange them in the ascending or descending order of the power of one variable. So in this case, we choose a as the variable. So a to the power 2 are clubbed together, and then we keep the terms with the power 1 of a, and then we keep the terms which have 0 power of a. So we get a square b minus a square c minus b square a plus c square a plus b square c minus c square b. Now, we see clearly that in this first group, we can take out a square as the common factor and we get b minus c. In the second, where the power of a is 0, we can take out minus a and we get b square minus c square. And in the last, we get bc common and we get b minus c. Now, breaking down b square minus c square using the identity, and then we put it as a product of b minus c and b plus c. So as we see here. So now we can clearly see in all the terms b minus c is the common factor. So we take that out and the remaining expression becomes a square minus, it becomes minus a multiplied by b plus c, which I have opened in the single step. So I made it minus ac and plus bc. Now again we rearrange them in the reducing order of the power of a. So we put the a square here and we get the two numbers with the power 1 for a, and then we keep the last term as this. Now in this, we take out a common from the first two terms and we get a minus c in the bracket, and we take out minus b from the last two terms and we get a minus c there. We get minus b common and then a minus c. So now again using the distributive property, we get this as a product of b minus c into a minus c into a minus b. So these are the three factors that are there for the given expression. So that is how we factorize the cyclic expressions. Now let's talk about the division of polynomial using factorization. So these are the different methods that we use for factorization. Now this is division of polynomial using factorization is one of the usage of factorization. Now some polynomial to polynomial division can also be carried out using factorization. In our algebraic expression division session, we've talked about how do we do polynomial to polynomial division using long division method. So now we are saying that, instead of using the long division method, if you could do certain division using the factorization, it may be a faster and a smarter approach wherever possible. It may not be possible at all the places, but wherever possible, yes, this is definitely a much faster and a smarter approach. So let's now take two polynomials. One is 10x raised to power 4 minus 30x cube minus 180x square, and the second is 5x square minus 30x, and we have to divide the first expression by the second one. Let's see what do we do. Now in the first expression itself, we can clearly see that we can factorize it to 10. We can bring out 10 common, and we can also bring out x square common. So after factorization, it becomes 10x square multiplied by x square minus 3x minus 18. And the similar thing we do here in case of the denominator, where we bring out 5x as the common factor and we divide it with, and we get x minus 6 in the brackets. So now after doing that, we can write 10x square as 5 into 2x square, and we can also factorize x square minus 3x minus 18 using the splitting the middle term method, and we make it x square minus 6x plus 3x minus 18, and the denominator remains as such. So now here, looking at this term using the splitting the middle term method, we can factorize it into x minus 6 plus 3 into x minus 6. We're just taking the common factors out as we've discussed in the previous slides. And now we have, in this step, we've cancelled 5x from the denominator with the 5x from the numerator. So we get in the numerator 2x multiplied by this expression. Now we factorize this expression, which was x square minus 3x minus 18, to x plus 3 multiplied by x minus 6. And in the denominator we have x minus 6, which can be cancelled out with the numerator. So we get, by cancelling x minus 6, we get the final result, which is 2x into x plus 3. So now this is an easier, faster and smarter approach of doing the division in this case where the division by factorization is possible. Now let's try to understand what is 0 of a polynomial. The value of the variable for which the value of the polynomial becomes 0 is called 0 of the polynomial. Now this, why are we talking about 0 of the polynomial in factorization, is because we can find the 0 of the polynomial using the factorization method. If x minus a is a factor of the given polynomial, then a is the 0 of the polynomial, which means, say for example, we take the expression x square minus 4 and we factorize it as x minus 2 into x plus 2. Now if we need to find out the 0 of the polynomial, we know that either of the factors of the polynomial, which is x minus 2 and x plus 2, so either of these factors need to be 0. So that means x will either be equal to 2 or equal to minus 2, and these two values of x will result in this polynomial becoming 0. So that is why these two values of x are called zeros of the polynomial, and they can be found using the factorization method. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.